Hello everyone, welcome back to another session of Additional Mathematics. Today our focus will be on coordinate geometry. I am Mr. Saman and will be your facilitator throughout this session. Let us now take a look at the objective for today's session. We will find the equation of a straight line. But just before we go into finding the equation of a straight line, let us review some background information about key concepts needed to properly maneuver this topic. Let us start with the distance between 2 points. How do we find the distance between 2 points on a line? To find the distance of A and B, we realize that we can use the concept of Pythagoras' theorem from trigonometry. And remember that Pythagoras' theorem states that the square of the hypotenuse side equal the sum of the squares of the other two sides. Now, since you have the two sides being y2 minus y1, that is the vertical side, while the horizontal side is x2 minus x1. Therefore, when you apply the Pythagoras theorem, you will end up with a formula looking like this. And this is the formula that you use to find the length of a line. That is, AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Let us now take a look at how we find the midpoint of a line segment. Now again, we have 2 points, A and B. And since we know that midpoint is a representation of the middle of the line segment, then what we need to do is to find halfway between the x and y values. In other words, you find half of your horizontal values, which is x1 plus x2. Now we are going to look at the gradient of a line segment. Keep in mind that gradient is basically representing the slope of a line. And whenever you are finding the gradient of a line, it is the vertical change written as a fraction of the horizontal change. In other words, the gradient will be m equal y2 minus y1 of x2 minus x1. And this is how you find the gradient of a line segment. Gradient of parallel lines. Now, when two lines are parallel, it means that they have the same distance apart. And their gradient will also be equal. As you can see here, both lines have the same gradient. If we have two lines that are perpendicular, then there is something special about their gradient. The gradient of both lines that are perpendicular, they are negative reciprocals of each other. In other words, if one line is being represented by a gradient of m1 and the other is being represented by a gradient of m2, then the product of their gradients should give us -1. Let's now go into the equation of a straight line. So now we are saying the equation of a straight line is the common relation between the x and the y coordinates of any point on the line. Now, the equation of a straight line can be written in gradient intercept form, which is y equal mx plus c, where m represents the gradient and c represents the y-intercept. It can also be written in the general form in which ax plus by equal d, where a, b, and d represents real numbers. And now we will look at three basic forms of writing the equation. One, the gradient intercept form. Given a line that intercepts the y-axis at a point, let us call this point Q, 0C, with a gradient m and a general point P, xy, line on the line. Let us see what happens in this case. Now, as you can see this diagram, the line runs directly through the y-axis. And that point is indicated by the letter Q, while P is a point on the line as was stated before. And since we are now going to find the equation of a line, we are now going to look at how we find the gradient of this line. So in this case, the gradient can be represented by m equal y minus c of x. After we have rearranged this equation, then you will get y equal mx plus c. And keep in mind that this is the most common form of equation used in this course. Let us look at the second form, which is the gradient point form. Now, given a line passing through the point Q, AB, with gradient m and a general point P, xy, line on the line, we are saying that to find the gradient of this line, then it will be m is equal to y minus b of x minus a. When we rearrange that equation, you will get y minus b equal m into x minus a. And as you can see in the diagram, it represents the 2 points that we have made mention of earlier. And keep in mind as well that this is the most useful form of the equation used in later courses. The third form that we will look at is the double intercept form. And remember, when we say double intercept form, we are speaking about the y-intercept and the x-intercept. And here, they are represented by P, 0 of A, and Q, B, 0. Let us look at how we find the gradient of such a situation. The gradient of the line y minus a of x is equal to negative a of b. When we rearrange this equation, then we will get ax plus by equal ab. Now, right here, we realize that all of the equations and all of the forms that we have looked at just now, they can be rearranged to form one or the other. They are really different ways of writing the same thing. Now let us take a look at an example. Find the gradient intercept form the equation of the line through -1, 3 with a gradient of 5. Now keep in mind that your answer must be in the gradient intercept form. And right here we see that we were given a point along with the gradient of 5. So let us now look at the solution for this question. So first, we would like to look at our point, which is -1, 3. You can label this point as x1, y1. And you can utilize the concept that you have just gone through, which is the gradient intercept form. So, in this case, we have y minus 3 is equal to 5 into x minus -1. You can now go ahead, simplify this equation, and ensure that when you are through, you will leave it in the gradient intercept form. When you simplify, you will get y is equal to 5x plus 8. So now you have your equation in the gradient intercept form, which is the same as y is equal to mx plus c. Let us take a look at a second example. Find in general form the equation of the line with gradient 3/4, which passes through 5, -2. How do you go about finding the equation for this information? Since you have mastered some concepts from CXC, I want you now to pause this video. Go ahead, try it, and you resume the video. Let us now go through the solution of this question. So, what do we have so far? We realize that we have a point, and we also have the gradient. So let us now use the gradient point form to find the solution of this equation, which is y minus a -2 is equal to 3/4 into x minus 5. Now, if you have not done so, I would like you to pause this video, go ahead, simplify this equation so that at the end you have the equation written in the general form. Let us go. After we have simplified, we have 4 into y plus 2 is equal to 3 into x minus 5. And after simplifying all of that, you will get a result of 3x minus 4y equals 23. And right here, you have the equation written in the general form. Let us now take a look at a third example. And in this case, I would like you to pause the video and go ahead, try them for yourself, and then you return to go through the solution with us. The first question is 3x plus 4y equal 12. Next question is y minus 3 equal 2 into x plus 4. And the third question is 4x minus 2y plus 9 is equal to 0. And we must find the equation, find the gradient, and the y-intercept of these lines. So go ahead, and find the gradient and the y-intercept of these lines. Let us now go through the solution for each of them. Our first line is 3x plus 4y equals 12. How do we go about finding the gradient of this line? Right, so we can go about this by rearranging your equation. After rearranging your equation, you will get y is equal to negative 3/4 x plus 3. Now, what is your gradient and what is your y-intercept? So remember that in this form, it is written in y is equal to mx plus c, where m is the coefficient of your x and c is the constant. Therefore, we have our gradient as negative 3/4 and your y-intercept as 0, 3. Let us now look at the second question. Y minus 3 equals 2 into x plus 4. I know you have solved this question already, but we will now go through it together. So rearrange this equation so that it resembles y equal 2x plus 11. Again, it is in the form y equals mx plus c. And in this case, your gradient m is equal to 2 and your y-intercept is 0, 11. And the final question that we are going to go through is 4x minus 2y plus 9 equals 0. What do we do in this case? Keep in mind your intention is to find the gradient and the y-intercept. So we go about rearranging this equation. When you rearrange this equation, you will get y is equal to 2x plus 4.5. Very good. And you have seen here that your gradient is 2 and your y-intercept point is 0, 4.5. So here you have accomplished your objective. You have also reviewed key concepts that will be necessary going forward into this course. When we return for the next session, we will look at other concepts relating to equation of a line. Until then, keep practicing and all the best.